Right now, you're understanding every word I'm saying without even trying. Your brain is taking sound waves, turning them into meaning in real time automatically. But here's the strange part. No other animal on Earth does this. Dolphins are smart. Chimps are smart. Crows solve puzzles. But none of them sit around discussing what happened yesterday or what might happen tomorrow or why the sky is blue. So somewhere in our past, something changed. A switch flipped. And humans became the only species that could talk. Today we're going to dig into how that actually happened. And the honest answer is nobody knows for certain. But we have some incredible clues. Let's get into it. Why this is such a hard question. Before we get to the theories, you need to understand why this is one of the toughest problems in science. Words don't fossilize. You can dig up a skull, a jawbone, a piece of pottery, but you can never dig up a sentence. Speech happened, people talked, and then the sound was just gone. Forever. Because of this, in 1866, the Linguistic Society of Paris literally banned any papers on the origin of language. They were sick of wild, unprovable speculation. For over a century, serious scientists mostly avoided the topic completely. It's only in the last few decades, but with new tools in genetics, brain imaging, and animal cognition, that researchers have felt confident enough to take the question seriously again. So, what do we actually have to work with? 3 things: bones, brains, and behavior. Clue 1. The body had to change. First, before humans could speak, our bodies had to be physically capable of it. Take the tongue and throat. In most mammals, the voice box, the larynx, sits high up in the throat. This lets them breathe and swallow at the same time, which is why your dog can pant and eat without choking. Human babies are born this way too, but as we grow, our larynx drops lower into the throat. That drop creates a bigger resonating chamber above the vocal cords, which lets us produce a huge range of distinct vowel and consonant sounds. It's part of why humans can make so many more speech sounds than other apes. Then there's breathing control. Speaking requires incredibly precise control over your breath, stretching one exhale across a long sentence. Researchers studying ancient hominin skeletons look at the thoracic vertebrae, the bones in the mid-back, because the nerve canal there is noticeably wider in humans than in earlier ancestors like Homo erectus. A wider canal likely means more nerve fibers, which likely means finer control over the chest muscles used for breathing. And finer control over breath means finer control over speech. So the body was quietly getting speech ready long before anyone said a single word. Clue 2. The brain had to rewire. A voice box is useless without a brain that knows what to do with it. In the 1860s, a French doctor named Paul Broca studied patients who had lost the ability to produce speech after damage to a specific spot on the left side of the brain. That region is now called Broca's area, and it's linked to producing language. Shortly after, Carl Wernicke found a different brain region tied to understanding language. Damage there, and people could still talk fluently. But the words made no sense. These discoveries told scientists something huge. Language isn't just one thing in the brain. It's a network. Separate regions for producing speech, understanding speech, and connecting words to meaning, all wired together and firing in sync. Genetics adds another piece. There's a gene called FOXP2 that's been nicknamed, a little dramatically, the language gene. It's not actually one single language switch, but mutations in FOXP2 are linked to real difficulties with grammar and coordinating the muscle movements needed for clear speech. Comparing the human version of this gene to the version in chimpanzees and in Neanderthal DNA extracted from ancient bones gives researchers a rough timeline for when our version might have evolved. None of this proves exactly when language turned on, but together it paints a picture. Bit by bit, natural selection was building a brain suited for language, long before anyone knows if it was actually being used. So, when did people actually start talking? Here's where the real debate lives. Researchers roughly fall into 2 camps. Camp 1. Language emerged gradually. In this view, our ancestors started with simple calls and gestures, similar to what you see in other primates: pointing, grunting, miming, and action. Over hundreds of thousands of years, these building blocks slowly combined into something more structured. First simple words, then basic word combinations, then full grammar. Under this view, something like language could stretch back 1, maybe 2 million years, tied to species like Homo erectus and Homo heidelbergensis. Camp 2. Language appeared suddenly. Some researchers, most famously linguist Noam Chomsky, argue something different: that a single genetic mutation, maybe around 70,000 to 100,000 years ago, rewired the brain to allow recursive, structured thought. The ability to nest ideas inside other ideas, like the man who saw the dog that chased the cat. In this view, that one change unlocked full language almost instantly, at least on an evolutionary timescale. Interestingly, this second timeline lines up with something archaeologists actually see in the physical record: an explosion of symbolic behavior around 70,000 to 100,000 years ago. Suddenly, humans are making jewelry, carving patterns into ochre, burying their dead with tools and ornaments. Some researchers see this as the visible footprint of language finally kicking in, because once you can talk, you can share ideas, pass down skills, coordinate for a hunt, and warn each other about danger, generation after generation. Most researchers today land somewhere in between. Physical and cognitive groundwork built up gradually, but the emergence of full grammar may have come together relatively fast in evolutionary terms. What about gesture? There's a fascinating theory that speech wasn't actually first. Gesture was. Watch a chimpanzee or bonobo, and you'll notice something. Their vocal calls are mostly fixed and automatic. A fear scream, an alarm hoot, while their gestures are far more flexible and deliberate. A chimp will reach, point, tap, or wave to intentionally communicate to another chimp, adjusting the gesture based on whether it worked. This has led some researchers to argue that early hominins may have communicated primarily through gesture first and vocal language layered on top later. Possibly because gesture requires you to be looking at someone, while voice works in the dark, around a corner, or with your hands full gathering food or carrying a baby. You can actually still see the fossil of this today. Try telling a story without moving your hands. Almost impossible, right? Some researchers believe that's not a coincidence, but it's a leftover of a communication system that was gestural before it was ever vocal. The social pressure theory. Here's a theory that isn't about the brain or body at all. It's about relationships. Anthropologist Robin Dunbar has a compelling idea. Language evolved as a replacement for grooming. In primate groups, grooming, while picking through fur, removing bugs, isn't just hygiene. It's social glue. It builds trust and alliances. But grooming only works one-on-one, and it takes time. As early human groups grew larger, Dunbar argues, one-on-one grooming became impossible to keep up with everyone. Talking solved this. You can groom, bond, gossip, check in, build trust with several people at once while your hands stay free to do something else entirely. Under this theory, language wasn't first about mammoths and tools. It was about people. It was gossip, alliance building, and keeping the group together, dressed up in a much more efficient package than picking lice out of someone's bag. Why this question matters? So why does any of this matter beyond trivia night? Because language may be the single biggest reason humans went on to build cities, write books, invent the internet, and yes, make YouTube videos about the origin of language. It let one generation pass hard-earned knowledge to the next without having to relearn everything from scratch. It let humans coordinate in large groups toward a shared goal. It's arguably the most powerful piece of technology our species has ever produced. And it isn't made of metal or code. It's made of sound. Here's the honest truth. We may never know the exact day, the exact person, or the exact moment when the first real sentence was spoken. That moment left no fossil, no footprint, no trace. But by piecing together bones, brains, genes, and behavior, scientists have gotten remarkably close to understanding how it probably happened. A slow building, then possibly fast clicking combination of body, brain, and social pressure that eventually gave rise to the thing you're using to understand this video right now. If you found this interesting, let me know in the comments what you'd want covered next. Maybe how writing was invented, or why languages evolve completely differently across the globe. Subscribe if you want to see it. Thanks for watching.